First of all, congratulations for securing admission in class 11, especially in the branch of science. I hope everything is going well for you. You got admission into a new school and you also made a lot of new friends. And I hope you are very excited about the journey you are going to experience for the next 2 years. With this excitement, let us start the first chapter in mathematics in the syllabus of CBSE board. The first chapter is set theory. Okay, first let us go ahead and discuss what we are going to learn in today's lecture, that means lecture 1. We will start with how set theory started. Next, we are going to learn about one small thing which is known as collection. We are not directly going to jump into set. We will first learn collection and 3 simple but most important ideas. When we are ready understanding these concepts, then we'll move to what is sets with its example and how to write sets, that means representation of sets, and we'll give and discuss few examples as well. Let us start with origin of set theory. More than 150 years ago, there was a mathematician, in fact Russian mathematician, his name was George Cantor, and he was working on a very difficult research problem. What he did at that time, to simplify the mathematical ideas, he used some kind of diagram which we are going to learn in future as Venn diagram, and it helped him to understand those difficult concepts in a simple way. And probably at that time he didn't know that the mathematical concepts and theories is going to develop later will become very important for all the mathematicians and will use in day-to-day life. Now, talking about applications, set theory concepts are very important, and these are important pillars of mathematics, and the mathematicians use it almost every day. Especially it has a lot of use in a field of mathematics known as probability and statistics. You are going to get a glimpse of those via a chapter known as probability and statistics in class 11 or class 12. Also, it makes real world problems easier to solve. Currently you are probably in class 11 or 12, and few years after now you'll be in undergraduate or postgraduate. At that time you will be appearing for competitive exams like railway or banking, etc. There you will find that on those competitive exams there will be a lot of problems. If you use set theory concepts, those problems becomes easier to solve. So that's why this chapter is going to be very important for us. It will help us in future as well. So let us start with concept of collections. Collection is derivation of the word collect. So what is a collection? Collection is a group of objects or items that are gathered together. Basically, whenever you gather or collect a lot of items, that entire thing, the gathering is called a collection. Examples: when we go to the school, before going to the school, what you do, we grab a lot of pens in our home, right? And we put it in our school bag. So the pens in your school bag is actually collection of pens or pencils. Next, probably we all have some kind of fruits at our home. So the fruits in the basket are actually collection of fruits. One more example, I don't know about you guys, but when I was a kid, I loved playing Ludo. Right now, probably you do also play, but since the technology has advanced, you play probably in your phone. But in my time, I used to play in a board. So in a Ludo, what happens? You take a dice, you roll it, and it gives you some number, right? There are 6 numbers written on different sides of the dice. If you roll the dice 10 times, you're going to get 10 different numbers. And if you list all those 10 numbers, that will be a collection. Collection of what? Collection of 10 numbers obtained by rolling the dice 10 times. Now we are going to learn 3 simple but important ideas, starting from distinct. When you have a lot of items gathered, what does it mean when you call the items are distinct? The items are distinct when they're different from each other, or each item in the collection or in the gathering are unique, or they don't have any duplicates. Next idea is independent of order. When you have a collection of elements or items, when we call it the items are independent of order, that means their arrangements or sequence of items in the collection does not matter at all. And finally, the last concept we are going to discuss, the idea we are going to discuss is well-definedness. So something is being well-defined means it is clear, precise, and easy to understand. For example, if you ask the question to anyone, they all give you the same answer. So now we have an important thing to note, that whenever we have a collection, the items or elements in the collection may or may not have the importance of order. They may or may not be distinct, and the collection may or may not be well defined. Now we are going to discuss it one by one. We will first see the examples of collection where the items in the collection may or may not have importance of the order. Starting from, let's see when the order is important in a collection. Let us take an example of, let's start with food. I don't know about you guys, I love going to wedding receptions. Not because I'm a good friend with the bride or groom, because of course the food. So when you go there during the reception dinner, what happens? Before the food is served, someone hands you over a menu card. And in the menu card, the items going to be served are listed in a particular order, right? Usually that order is starting from some kind of appetizer like pakoda, salad, etc. And then main course like rice, dal, butter paneer or puri, and finally ending with some dessert. It could be rasgulla or ice cream, etc. Imagine that the food is served to you in a random order, maybe starting from ice cream, and then they served butter paneer, and then maybe salad, and finally when you are about to finish your dinner, they served you rice. It is going to be very awkward and nobody is going to enjoy this kind of order of food served, right? So when you have a menu there, the list of food items, the order of those things are very important. Next, I know you all guys are very studious and you go to library for issuing books, right? So when you go to the library, what you see? They have a big collection of books, and the elements of the book collections are the books itself, and they are actually kept in the library in some kind of order. Probably the librarian assigned the books in some kind of numbers, 1 2 3 4 up to, I don't know, the number of books are there, and or maybe in order of the last name of the author or something, or the name of the subject. There is a reason they keep it in this way, because when you go to issue a book, it becomes easier for the librarian to find a book or locate a book. But if they keep the book in a random order and you ask them a maybe mathematics book of a particular writer, then it will become very difficult for them to find the book. So books in the library, if it is a collection of books, then there need to have some kind of order in its elements. Next example is, what if I ask you to write all the events in Indian history in a chronological order? Then you are going to list all the events one by one in a particular order. If you randomize the order, if you write in whatever order you remember the events, it is not going to work. That will be a collection of events in Indian history, but that will not be a chronological events. Next, let's say you ordered something from Amazon, a furniture, maybe it could be a table or a chair. You see that the entire table or chair doesn't come in one piece in a big package. No. Amazon sends you small parts of the furniture and you have to assemble those at your home. Also, there is a instruction sheet along with that tells you steps in order to assemble the furniture. Those steps written in the instructions are very important. If you don't follow those steps in correct order, you are going to mess up the assembly of the furniture. Same goes for cooking. I hope you guys started cooking a little bit. You are going to need it in future for sure. So when you have a cooking recipe, let's say you are trying to cook butter paneer. So when you see the recipe, which is nothing but collection of step-by-step instruction to make it, you have to follow the order wherever you are taking recipe from. If you don't, you are going to mess up the food. For example, let's say for making butter paneer, first you have to turn on the stove, you have to put a vessel like kadahai, you have to add oil, you have to then add onion, chopped onion to fry, and then masalas and paneer and so on, it goes on. What if you change the order? Let's say you added kadhai, and instead of adding the next step, putting oil, you added onion, you fried it without it, and then you put masalas and you put whatever paneer, and just before you finish your cooking, you added oil. It is not going to taste good, right? So that instructions for assembling furniture or cooking a recipe is also called, it could be called a collection, right? Collection of those steps for doing this particular job, and here the order is very important. Finally, we all like watching IPL, Indian Premier League. I hope that you went to see the at least one IPL game in person. So in order to that, first you have to get IPL tickets, and in the tickets they put a number which is called as ticket number, right? Why they put it? Because each ticket number is associated with the seating arrangement in the stadium, right? If they don't put ticket numbers in the tickets, what is going to happen? Then people will have difficulty finding their seats in the stadium, and there will be big chaos, right? So if you consider this kind of collections where we just discussed, their order is important always. Now we are going to discuss the opposite. We are going to see examples of collections where order is not important. That means it doesn't matter how you gather how you build the collection by gathering its elements, it doesn't affect the collection at all. So let us start with the example of collection of pens in your school bag. We just discussed. No one goes to the school with just one pen, right? You may run out of ink. So you just grab a lot of pens and put it in your school bag. Do you pick up the pens in order? No. Similarly, when you arrive at a school, and probably if you are late for class, when you get the pens out of the school bag, do you get them out in some kind of order? This is my favorite pen, this is my second favorite. No. You just grab a pen, you put your hands in the school bag, grab a pen and start writing. So for the collection of pens in your school bag, the order is not important. Same for items in grocery list shopping. I don't know about you guys. When I was in class 11 and 12, my mother used to send me to fetch grocery items whenever I'm deeply focused in the study. Very funny. So whenever she assigned me this particular job, she was giving me a lot of items to fetch, to bring, right? At least like six or seven items, and I had very weak memory at that time. I still have, but at that time as well. So I used to write all those items in a small piece of paper so that I won't forget. Now, the items I have listed on the piece of paper, their order is not important because my mom doesn't care about which order I bought or which order I bring those items at the home. I can buy those things in any order. She just wants all the items when I return home, right? So for the collection of items in a grocery list shopping, their order is not important. Same. Let's say you have a birthday next week. You created a WhatsApp group chat in order to communicate with your friends. So when you create the group chat, what you do, you start adding friends one by one. Does it matter in which order you add your friends? No. After adding your friends, whenever you send any message, all of your friends get the message. There, in which order you added the friends, it doesn't matter at all. Next example, fruits in a basket in your home. Same. If you have fruits in the basket somewhere in your home, when you bought those fruit items and emptied it in the basket in your home, you did not put in a particular order. You just emptied it. Similarly, when you try to grab one fruit when you are in a hurry, you do not pick up fruits in a particular order. You just grab whatever you get. Next, toppings in pizza. Let's say you are buying a pizza from, I don't know, some pizza store. So what you have to do, first you have to tell the person at the counter that what toppings you would like in your pizza. Let's say you like onion, olives, paneer, etc. on your pizza. So when the person who is making the pizza prepares the pizza, it doesn't matter in which order he or she puts the toppings on the pizza, right? Will it taste differently if you put olive on the top of onion or onion on the top of olive? It is going to taste the same when the pizza is prepared, right? So there it doesn't matter. We are done with importance of order. Now we are going to discuss about distinctness. So let us discuss when items in a collection are distinct. Distinct means occurring only once, or the items does not repeat. Some collections requires distinct elements. Starting with example, let us take collection of all the students in your class. If you assemble or gather all the students in a particular classroom, you see all the students in this class are distinct. They are different from each other. No students repeat, right? So this collection, that means collection of all students in your class, for this kind of collection, the items means the students are actually distinct. Another example, you have seen sports teams, right? Let us take cricket team for example. So if you have seen a cricket match in television, you see all the players wear a jersey with a number written in the jersey, and you will probably observe that everyone has a different number on their jersey. No two players of the same cricket team have the same numbers, right? So if we consider a collection of jersey numbers in a cricket team, the items or elements in this collection, that is the jersey numbers, are distinct. Next example, Gmail addresses of the people. No two person has the same Gmail address, right? Another example, phone numbers of all the people. Same explanation. Bank account number in a bank. Everyone has a different account number. Players selected for a particular league. Same explanation. House numbers in a society or housing complex. Everyone has a different house number in the same locality, right? Or same society. Ingredients in a recipe. When you have a recipe to make something, the ingredients are always distinct. Now we are going to see the examples of collections where the items don't necessarily need to be distinct. That means some collections may require its elements to be repeated. Let us start with the example. Collection of fruits a street vendor sells. Probably you have visited market, right? So whenever you find a fruit seller or fruit vendor in a street, what do you see? They have multiple buckets, and in each bucket they have lot of fruits of same kind, right? So if you consider this as a collection of fruit he's selling, so there are a lot of fruits which has multiple copies or multiple fruits, I would say, same kind of fruit. So there the items are actually not distinct. Another, I don't know about you guys, but in my school, specifically in my class, there two of my friends has exactly first and last name. So if we consider the collection of names of students in your school, it is highly likely that two students may have same names, right? So if we create a collection of names of students, then some of the elements, that means the names, may be repeated. Next, books in library. When you go to the library, you see that there are multiple copies of the same book in the library, right? And the reason is because then multiple students will be able to access the same book, right? If they keep only one copy, then it will be very difficult for all the students, right? Only one copy. If you go to a bicycle shop for buying this bicycle, what do you see? The seller keeps multiple copies of the same bicycle model, right? So these are the example of the collection where their items are actually not distinct, not always distinct. Now, the final concept we are going to learn, well-definedness. We already discussed something being well-defined means it is clear, precise, and easy to understand. When we are talking in the perspective of collection, a well-defined collection has the following properties. First, clear membership. That means which elements will be in this collection and which will not be in the collection will be clear to us. Second, we'll have some kind of precise criteria for the inclusion. And finally, when we are creating the collection, which items we should include or not, it will be unambiguous, will not be in like some kind of confusion. Example of well-defined collection are collection of subjects in CBSE class 11 in the branch of science. Why it is well defined? Because for creating this collection, I have gave you enough information so that we'll have an idea about the membership. We made it precise by giving you a lot of information like CBSE board, class 11 in the branch of science, and because of this, it became unambiguous. And you ask this question to everyone who knows about CBSE board science subjects in class 11, they will always have the same answer. Next, cricket team playing in IPL 2008. Whoever who have seen IPL 2008, they know what cricket teams played, right? Everyone will give you the same answer. Here, the cricket IPL 2008, by providing all this information, we made it like very precise, and it becomes easier for us to find out which will be the members, that means which cricket teams will be in this collection. Similar example, months in a year. Everyone will give you the same answer starting from January, February, March up to December. Same for if I ask you to write days in a week. It is unambiguous, precise, and we know which elements will be its members starting from Monday, Tuesday, Wednesday up to Sunday. Now we are going to see the example of not well-defined collection, and we'll see that it is exactly of what we learned for the well-defined collection. In a not well-defined collection, it has one of the following properties. Starting from it will not have clear membership. It will have subjective membership. If you ask different person to create a particular collection which is not well-defined, the elements will always be different for different people. We'll see it through the examples. And there will be no specific criteria. That's why this subjective membership will occur, and there will be always ambiguity, like the collection is not clear to people whenever you ask them to create the collection. Let's start with the example. Collection of, what if I ask you what are the delicious Indian sweets? Everyone has a different preference, right? So different people, when asked this question, they will answer it differently. For me, it is malai cham cham. For you, delicious sweets could be rasagolla, or could be pantua, gulab jamun, etc. Right? Taste is subjective. That's why everyone will come up with different items in this particular collection. Next question, if I ask you to create a collection of beautiful places in India, again, different people like different things. Some people like nature, some people like city vibes. So different people will come up with a different list. So these are not well-defined collection. Same for what if I ask you to write the best 3 batsmen in the world. People are gonna write the names of the batsmen whom they admire, right? And different people have different criteria for admiration. Some people like humbleness. Some people like technicality. Some people like they will define the best 3 batsmen based on strike rate, etc., etc. So best is subject to personal bias. And the final example, what if I ask you to tell me the names of tall students in your class? This is not well-defined collection because that lacks precision, right? Now, and also ambiguity. It has ambiguity because you don't know whom you are going to call tall students. Is there any particular number like 5'5", 5'4", or 5'6"? If a student is taller than this height, then they will be called tall, or what, like you don't have a particular parameter by which you are going to judge which students are tall. So different people will come up with different answers.